Okay, question 17. For the circuit below, which one is true? Okay, the lights are the output, so this one wrong already. Okay, then they say buttons, lights, buzzer are all output. No, okay, buttons are input. Okay, so this one wrong also. Everything input, of course, not correct. Buzzers are outputs. Okay, so this one must be the answer. Okay, this is quite a trivial question. Okay, the two buttons are input, the two lights and two buzzers are output. Okay, so this one, I think you don't study, you also can pass. Okay, this question. Okay, what is the purpose of power on reset? Okay, that means you see your microcontroller board, there's a button, the black color one. When you press, you will reset the microcontroller. This question is asking what is the purpose of the reset. Okay, so okay, the answer is to prevent glitches and ensuring proper initialization. Okay, maybe I just highlight to you what is actually the power on reset. Okay, the power on reset, you can actually do something like that. Let's say this is the microcontroller. This is your STM32. Okay, there is a pin. Okay, that is for the reset. Okay, for reset. Now usually it's active low. Okay, so normally you can do this one. You have a pull up resistor. Okay, maybe this is 3.3 volt. Okay, 3.3 volt. Then you have a button. Okay, maybe I show it as a switch like that. Okay, there may be or may not be a small resistor here just to protect. Okay, now if you want to reset the STM32, all you need to do is close this one. Okay, connect this point to low. Okay, because it's active low. Okay, it will be reset. Okay, then of course the button will bounce back. Okay, become open. Okay, and then that point become connected to high. It's an active low signal, you connect to high. Okay, it's not being reset. Okay, so the thing is you close to reset it. When you release, it become tied to high, and then it's a normal operation. Okay, now what is the purpose of the this reset circuitry? Okay, is to ensure proper initialization, so that the microcontroller start at the maybe first line in the code. Okay, now this one prevent glitches. Means maybe for some reason the microcontroller has gone haywire. Okay, you want to start from the initial thing. Okay, this one set all the GPIO pins as output floating. This one is not correct. Okay, I think I can explain to you why not correct. I think in the tutorial we discussed that very often. Okay, when you reset the pin, there will be the configuration register, okay, low or configuration register high, okay, will have this value 4, 4 and so on. Okay, 4. Okay, now of course each 4 is the bit 0, 1, 0, 0. Okay, and this one is for the mode. Okay, mode. Okay, and this one is for the config, CON, or CONF. Okay, now if 0, 0 tell you is input. Okay, and then if it's 0, 1, then it's actually floating input. 0, 0 is analog input. Okay, so actually all the pins, because it's 4 for every single pin, is actually configuring all the pin to be floating input. Floating input means this is the input pin. Okay, if internally, let's say there's a pull up, okay, then it's no longer floating. Okay, similarly, if internally there is a pull down, okay, there's a pull down, okay, it's no longer floating. Okay, so the question want you, okay, I press save. Okay, I should just undo. Okay, so the floating input is like that. Okay, nothing to pull up or pull down. Okay, now so the answer that you saw just now, configure everything as output floating. No, it's actually input floating. Okay, by default. Okay, but this one require you to remember that 4444 thing, hexadecimal 4 from the tutorial. Okay, now this one, why is it not the answer? To resume or to begin normal operation from an unknown starting point. Of course, the thing is here, okay? It's a non-starting point, okay? It's a maybe first line of the code, huh? Okay, so unknown is deliberately made this way, okay? So that is a wrong answer, huh? Okay. Okay, this one to upload the program from flash to RAM. This is happening in the computer, okay? Computer, you may have a hard disk to store your program, and then you have a RAM which can run faster, okay? For read and write, huh? Okay, so they will, in the computer, they will copy from the hard disk to the RAM to run, but not for the microcontroller. Microcontroller will run from the flash, okay? And then the RAM is just for storing temporary data. Okay, so the answer is A, huh? Okay. Okay, A is the answer, huh? Okay, next question. Okay, we have a switch connection. Actually, you have seen this one just now, okay? In case you have forgotten, okay? This was the one we had just now, huh? Okay, active low button, because you activate, it become low, huh? Okay, so we have the same connection here. Oh, okay, this is the difference. Okay, this button is normally closed, meaning that normally, okay, the button is closing the 2 point here. Okay, so the microcontroller will normally read a low here. Okay, when you press the button, okay, it will become open. Okay, normally closed, but when you press it, it become open. When it become open, the input pin will become connected to high. So this is a so-called active high. Okay, so it's an active high connection. Okay, A is correct here. Okay, now similarly, there's another answer which is correct. Okay, I will tell you in a short while. Okay, the B here say 470 ohm not required. Actually is you can remove this one to save cost. Okay, but it's good for protection. Okay, because this is actually input. Okay, if you make some mistake, for example, you make this pin an output. Okay, and then because here is normally closed, so if you don't have the resistor, that pin will be pulled to low. Okay, and then you happen to write a 1 here. You imagine you have a 5 volt or 3.3 volt here. Okay, connected directly to the ground. Okay, again, you're going to burn the thread. Okay, and then damage the pin maybe. Okay, so it's good to have the 470 ohm resistor here. Okay, so this B is not the answer. Now, before connecting to microcontroller, we can, okay, if you want, okay, this is active low. Okay, sorry, let me rewind. This is normally closed, so it's low. Okay, so when you press, it become high. Okay, now the question say, because of some component shortage, okay, you don't have this NC, okay, or normally closed button anymore. Okay, so what can you do? Okay, so you can use a normally open push button, okay, and then put an inverter here to achieve the same. Okay, so I don't know whether you understand what this thing is saying. Let me just quickly draw. Okay, for those people who need to. Okay, otherwise you just skip a few seconds. Okay, so this was the connection. Okay, normally closed, like that. Let me try to draw it. This is normally closed. Okay, so you have something like that, resistor to the pin. Okay, so here is 3.3 volt. Okay, so when you release, okay, release, okay, that means you don't press it. The pin will read a low. 0. Okay, so when you press, this one bounce back. Okay, when you press, okay, the pin will read 1. Okay, because you press it, the normally closed button will bounce. Okay, and the pin will read a high. Okay, so now, okay, the question say, I don't have the NC anymore. I have another kind of button which is normally open, like that. Okay, normally open. So you need to press it to make it close. Okay, so I have the circuit there. Okay, exactly the same circuit. I just replace that component with an normally open 1, huh? Okay, but this one, the logic become terbalik, huh? You can see, huh? Normally is high now, okay? So I put, huh? Release, okay? Your pin will read 1, huh? Okay, release, okay? When you don't do anything, the pin will read a high, okay? But when you press, that means you are closing that switch, okay? The pin will read a low, like that, huh? Okay, but if you want the behavior to be the same, what you can do is you put an inverter here. Okay, put an inverter here. Huh? Okay, of course this will change the logic to 0 here and to the 1 here. Huh? Okay, then you're back to the same as before. You just replace the component, but of course you need to add in the inverter here, which is what the question is saying. Huh? Okay, you can before connecting to the pin, we can put an inverter. Okay, and then make it work like as before. Huh? Okay. Okay, so A and C are the answer. D, of course, is wrong. It's the opposite of this one. Okay, A and C. Okay, active high, but if you have active low, then okay, you must. Okay, I mean normally close versus normally open. If you change to normally open, then you need to have an inverter here. Huh?